Hello everyone, welcome back to another edition of the Homework Helper. Today we're going to be looking at Lesson 5 from Unit 3. Here we're going to take a look at the ready questions 1, 3, 7, and 8, the set questions 10, 13, 15, 16, 17, 22, 23, and 25, and then we're going to finish with the go questions 26 and 30. So for the ready questions, we're going to be taking a look at numbers, and we're going to classify them into whatever sets in which they belong. All right, so for the number 1, we have the number pi, and pi is that number 3.14 and a bunch of other decimals. So it's not a whole number. It's not an integer because an integer is basically a counting number. It is a real number though. Now we got to think, is it rational or irrational? So think, can we write it as a fraction? If we can write it as a fraction, that makes it rational. We can't do that with pi. So pi is irrational. So the answer for this one is D and E. Number 2, we don't have to do. So number 3, root 625. This one actually, if you were to look at it, square root of 625. 625 is a perfect square. It equals 25. Or 25 squared equals 625. So this is a whole number. It's an integer. It's rational. And it's real. So this is A, B, C, E. Moving on to number 7. 7, square root of 4 over 9. The square root of 4 over 9, we can write that as 2/3. It's not a whole number though. It's not an integer. It is absolutely rational because we can write it as a fraction because it's already written as a fraction, and it's real. So this is just C and E. What's next? Number 8. 5 plus root 2. Not a whole number, not an integer. It is real, and the question is it rational or irrational? Root 2 is not a rational number, can't be written as a fraction. So this guy is DE. All right, so that should take us through the ready section. For the set section, we're going to do a lot of combining like terms. So let's just dive into number 10 here to get started. All right, so here, as I mentioned, combine like terms. So we have 3 minus 7. 3 minus 7 minus 4. We get root 2 plus 3 root 2. 1 root 2 plus 3 root 2 is 4 root 2. And there's our answer. All right, so we're just combining like terms. Number 13 is a little bit trickier. Let's go the root 8. I'll write root 8 in black here. So this can be rewritten as root 4 times root 2. The minus 18 is root 9 times root 2. And then the plus root 32. So you can split this up a bunch of different ways, but we want it to be in some form of root 2. So we're going to do root 16 times root 2. So keeping it consistent, 4 root 2. Root 4 times root 2 is 2 root 2. Minus the next one there is root 9 times root 2, so that's 3 root 2. And then finally, we're going to add root 16 times root 2, that's 4 root 2. So combining these three things together, we get 2 minus 3 plus 4, which leaves us with 3 root 2. Okay, so that takes us through 13, 15, 16, 15. Okay, so here we get our first look at an imaginary number here. We get root 7i squared. All right, so same thing that we would do normally, root 7i squared. Root 7 squared is 7. I squared is I squared. So I squared, one of the things we know about imaginary numbers, and this is kind of the first thing we learn about it, is I squared equals -1. So this ends up being 7i squared, we said, is negative 1. So that gives us negative 7. Number 16. All right, once again, combining like terms, 21 and 9 is 30. 4i and 8i is 12i. And there we have it. Number 17. Okay, so this one, before we lose sight of things, is this part right here. I'm going to rewrite this. So 6 plus 10i minus 2, and that minus sign gets distributed. So now that I'm writing it out like this, hopefully it's a little bit easier to see here. So we get the 6 minus 2 is 4, and we get 10 minus 5i, 10i minus 5i is plus 5i. So our final answer is 4 plus 5i. Moving on to number 22. Here we're going to we're going to treat it the same way we treated every other problem like this. We can FOIL it together or multiply it through foiling. There's going to be a little bit of a unique result to this. It's going to be a little bit different, and I guess we'll get there. But first step, 7 times 3 is 21. 7 times I, or negative I, is negative 7i. 3i times 3 is 9i. And 3i times I is minus 3i squared. Okay, so the real thing that happens that's unique about this one is involving that 3i squared right there. These guys you can combine, so that's 2i. Now this 3i squared, or minus 3i squared, is minus 3 times minus 1. Right, so that's really plus 3. So this ends up being 21 plus 3. So 21 plus 3 is 24. Number 23, I'm going to clean this up a little bit. Um, 23, so here we're multiplying what's called a number and its conjugate, and a unique situation that comes out of this, and we'll talk about this again in number 25, is that the I term gets canceled out. So when we're multiplying through here, right, 10 times 10 is 100, 10 times minus 3i is minus 30i, 3i times 10 is plus 30i. So here you can see that these guys right here cancel each other out, and then we're left with minus 9i squared. So this minus 9i squared ends up being minus 9 times minus 1. All right, so this ends up being 100 minus a negative 9. Or sorry, not minus a negative 9. It's going to be, I'll write it as plus 9. Equals 109. And we already talked about number 25. Right, notice that this gives us a whole number for number 23, multiplying by the conjugate. And the reason why is that term, that middle term, the I term, gets eliminated. And that's the major purpose of multiplying by a conjugate, is to get rid of the I values. So when you multiply two conjugates, will your answer always be a real number? The answer is yes. Right? The I term gets canceled out. Right? In a lot of cases, as I mentioned, that's the reason why you'd multiply by the conjugate, is to get rid of that I term, or to make it a real number. Okay, so that takes us through the ready and the set problems. All we have left is to finish two go problems, starting with number 26. This is kind of a throwback to some of the prior lessons that we've done in this chapter, or in this unit. We're going to solve for m. Right? Easiest way to go about doing that is to factor it. All right, multiplies to be 56, adds up to be 15. That looks like 8 and 7 to me. Oh, I wrote an X. It's an M. So that's going to be M plus 7 times M plus 8 equals 0. So here M can either equal -7 or -8. All right, that takes us through 26. Now 30 is a problem that up until this section would have been kind of unsolvable. Solving for x. All right, we would get x squared equals -4. And that is going to be a problem, right? Or it was going to be a problem. However, what we can do instead is we could say, okay, x squared equals 4 times -1, and we take the square root of both of these, right? We know that the square root of 4 is 2, or I should say plus or minus 2, and the square root of -1 is I, right? So I squared equals -1 square root, so I equals the square root of -1. All right, and our answer is x is equal to plus or minus 2i. Okay, I think that takes us through all of. Does that finish up? Yeah, we got. That'll do it for the fifth lesson for Unit 3. Okay, hopefully this was helpful for you. I will see you again next time. Have a good one. Thanks for watching.